Hello, everyone. Welcome to the Data Science Mentor Program. My name is Pablo. I am the founder, the host, and convener of the Data Science Mentor Program, a data science accelerated learning cohort, learning community. I am a data science professional, and my job in this cohort is, at the end of this program, is for learners to have little or no exploring the machine learning and data science application of solving problems. Yeah, that's what it is. And we're going to be using the tools here to solve real world problems. Right. If today's your first session, so you would notice that you should have access to the other 12 sessions in this introduction. Yes. All right, so today we are going to be looking at imputation of missing data and pipelines. And I know that this is it's pretty simple, and I figured it was important that we talked about it. But why is this coming at this point? It's coming at this point after we introduced feature engineering. And it's important because data imputation and creating pipelines is a feature engineering technique. Right, and we're just going to look at handling missing data using data imputation, and I'll just go straight to it. Right now, the first thing I'm going to do is I am going to create something really simple, right? And then I'll use when applying a machine learning model to data, we need to now find a way to replace this missing value, right? So that's what we're going to do. We're going to do that first. So let me get started with this. All right. So I'm going to now introduce a scenario where we have a missing value. Right, I'll introduce a scenario where we have a missing value and then go ahead to think around imputing that missing value. And it's missing values, imputing missing values could also be a way of, you can use a feature engineering technique to do that. Even though it's a simple exploratory data analysis type of workflow, but you can use it, and I think it's really important. So the first thing I want to do is I want to write from NumPy import NAM. I know it's sort of surprising to see that I can import from NumPy. You can also import from pandas and just import. You can take from pandas as a class, just import one of the functionalities. Now, what we are going to do is we're going to call this X. And remember that at every point we are mirroring the idea of data representation because we are working with the scikit-learn estimators. So we must almost always represent data for scikit-learn estimators, which is a feature matrix and a target vector. If I mention feature matrix and target vector and you're surprised at that, it means you need to go and check out the other videos where we did some introduction to it. Okay, so what I'm going to do now is I'm going to let me do this. I'm going to use the np.array on this, and so I'll use x.shape. So you can see that what we have here is typically the same thing we talk about a feature matrix, n samples, n features. So that is rows and columns. Now, also you can see typically when you're dealing with NumPy arrays, we introduce none, which are missing values. Now, today's session is pretty really simple. It's just the intuition you pick up from it that's important. Next, we are going to introduce Y. Remember, Y represents our target vectors. So in a real sense, X is our explanatory variables, which are those variables that when tweaked can affect what the target variable is. In essence, if I wanted to predict the salary of my employees, what I would tweak to predict the salary are the explanatory variables, and the salary itself is the target variable. That's what I'm looking at. So at every point, we're always creating X and Y's. So with this, I am typically going to now create like an array here, which is just like you mentioned here. And again, when we look at Y dot shape, you always see that again, it's like a target vector, which is just n samples. So we're almost always representing this. It's okay. I'll keep saying this, right? So that we can make sense of it. Now, what we're trying to do is we're trying to replace the missing values in X, right? Using a data imputation technique, right? And sometimes this approach being used is very application specific, right? So we won't really dive much into it. We're going to do deep dives later, but it's important at this point that to know that we can use a scikit-learn estimator to deal with missing values. We're going to use it to handle missing values, and that's what I want us to do here. Now, so yeah, just like that, we have X here. You can see that we have this over here, and we have this, and this could be, data. So we start off from a very small place like this. Now, the next we're going to do is we're going to call the model class, which is typically the steps we'll take. Now, for some reason, you may want to deal with missing values, and after understanding the problems, the distribution of the data, you come to a conclusion that using the mean of the distributions, either in the rows or columns, will serve to fill the missing values. Now, remember, there must be context for this. There's context. It's not something you come up with. So because I'm just trying to introduce this, because we'll be using them in the deep dive, it's important that I talk about it. Now, the next I'm going to do is I'm going to say, so, and how do we do this? If we're going to use a scikit-learn estimator to perform this, right? And so we're going to use scikit-learn provides us with something to do that. So from sklearn dot impute, yes, and then we'll import simple imputer. Yes, that's what we're going to use. Now, the next we're going to use is we're going to now create. Now, this is where is where we're going to instantiate the simple imputer, and the simple imputer works like this. With the simple imputer, it gives us the different options for how we can create impute, and I'll call this. Let me call this imputation strategy. I know it's a lot to say, but I wanted to use this. I'll call this the imputation strategy. Now I will instantiate the simple imputer, and inside the simple imputer has a sensible defaults here. And so you can see that by default it's checking out missing values that are none. Its default imputation strategy is the mean, and it will fill missing values with none. And also you can see that these are they are here. So you can see strategies, imputation strategies. If mean, if median, if most frequent, right? If constant, if an instance of it's an instance of callable, then now and then you can see and if it's true that it's missing, a copy of X will be created. If it's false, imputation will be done in place whenever possible. So, but that's not what I want us to look at because we're not going to do a deep dive. What I'm going to do is I'm going to look at the strategy. And I'm just going to, even though it's a default, it's a sensible default, I'll put it out here. And so what I do is I've instantiated imputation strategy. Now, the next I'm going to do is I'm going to create, so since we already have X, let me create X2. And inside X2, I'm going to say imputation strategy dot fit underscore transform what we have in X. So that's what we're going to do. And to that end, if I run this, now remember here we have X, and now we have X2. You can see that it's used the mean to fill in that, right? So typically, with this, we can now go on to say, look, we want to now. So that's when we do this, we can now say, okay, the next step is to now say, we now have a model, and maybe the model we want to use, it might be a linear regression, and with the linear regression, we want to fit X2 comma Y. So now we go on to fit what we have here, right? So when we go on to fit this, then we can go on to do a prediction and say and stuff. So just so you know that this is a very simple thing to do. You can use the simple imputer, just like I've done here, for you to fill in missing values. Is a thing. But remember that you have to do it again with you have to think about it in terms of context. You don't just fill in missing values. Now, the next one we're going to do, which is what we're going to do and wrap up for the simple aspect. These first 13 sessions were really simple aspect. The next sessions we're now going to be doing deep dives into machine learning models, right? The next one we're going to do is called pipelines. Now, pipelines are super important in machine learning because sometimes it becomes really tedious to do transformation the way we do it. So sometimes it's also ideal for you to string multiple steps together. And when you string multiple steps, then you want to have a processing pipeline, right? So think about maybe having a processing pipeline. Think about having a processing pipeline. Now, what can this processing pipeline do? One, it's just like we have done right now. We just impute. We created an impute, right? We used an imputation strategy to put in the mean, and then went on to do a prediction. But imagine a pipeline where we impute missing values, transform the features, maybe we'll transform the features, maybe now maybe we'll transform the features to quadratic. Now, at this point, when we're saying we're transforming a feature to quadratic, it means using a polynomial feature, we're sort of like making a square of it. right? So it's like polynomial features with 2 degrees. We've talked about that, so check it out. It's you have access to it, right? And then we now fit a linear regression model. So this is what we have to do. But instead of doing this individually, right, it's ideal to create a processing pipeline. So that's the whole idea. So it streamlines all the activities you're doing. And it is important to know that. So to create this pipeline, because again, you have to find efficiency in what you're doing. So to create this pipeline, you call the model class. Again, sklearn dot pipeline. Then you import make pipeline. That's the first thing you do. And you can see that this we're trying to get all this done. Now with this, what we do is with our pipeline, we just basically put all these guys inside. Now, what makes it interesting is you can just apply this automatically, right? So if after you've maybe done exploratory data analysis on your data, in order to reflect the model or the reality for which you want that model to, for which you want the model to, reflect or find the patterns that provide the, somewhat accurate output. You put them into a pipeline. So let's create a very simple pipeline. So we call this model, and we'll call the make pipeline. Now inside it, with this make pipeline, you can see we can construct a class, a pipeline from given estimators. So there are different steps we can throw into it, right? So we can do a bunch of things inside of it. So with make pipeline, it sort of gives us the opportunity to just throw in different estimators. And when we say estimators, you can see like make pipelines. You can see simple imputer, linear regression, and all that, PCA. All these are estimators. So make pipeline accepts different estimators inside. So the first estimator we would use is our simple imputer. And with our simple imputer, we'll take our strategy and say we're going to use the mean. The next one is we're going to use the polynomial regression or the polynomial features. And here we want to make it a quadratic. We're going to say in degree is equals to 2. Then the final one is we are now going to have a linear regression model that is inside out. Basically, we just fit the linear regression model to whatever we do to this, that tweaks this, sort of like squares it, and the features squares the features, and then we have this here. So with this, we just run this. Now we now have a model, and we typically wouldn't want to now do these two things we've done. So instead, we just simply come with our pipeline, we just say model dot fit. Now, what this model does is it does this. It's now this pipeline, so it does these 3 things to it. So I don't have to bother about X anymore. I know that X has missing values, so I just simply put X, and then I put Y, right? Now, remember, X has missing values. X has missing values. So, right? So which would tell us what it's going to do. So by the time I run this, you can see what happens. The pipeline does the simple imputer, runs the polynomial, runs its 2 degrees of the polynomial on it, and then fits the linear regression on it. And to that end, when I now say print, and I'll say model.predict. So this time I want to predict what we have with X. Right, it can now bring out what, if it was doing any prediction, it will. So you can see that right here, X over here had missing values, but it has already been dealt with, tweaked. Two degrees of polynomial degrees, and fitted into a linear model, and then we have a result. So all the steps are, you see, all the steps are applied inside, and it is just simple. Instead of having to, write them individually, you just create a pipeline, store everything you want in the pipeline, and run it. And from as you proceed, as you get new data, you update your pipeline, right? And yeah. So we're going to be using these things as we proceed, right? And so that's to make the work we have pretty, efficient. So yeah, so that's that for our introduction. We're going to, in the next session, we're going to now start deep dives, and in deep dives, we're going to take our time and build and think around problems, then build on them. All right, if you're in a live session and you have questions, please feel free to ask. If you are watching the recorded session, please drop your questions in the Telegram channel. And if you're fortunate and you're watching this on the live stream, or it's already been live, you can drop your questions in the comment section. A question?
Question, sir.
Yes, please.
Okay, in this imputation of missing data, is the difference basically from the normal Python pandas imputation of data, where we use fill now and the rest we fill with mean and mode? Is the difference just basically this is we fill the data in one code? What's the difference between this imputation we are doing with the normal filling of missing data with either with mean and mode? That is one. Then two, since we are using a pipeline, we know in trying to train our model, most times we do pre-processing, where we do either a label encoding or we do one-hot encoding. Since you're doing a pipeline now, will you do either of them, or you bring in another model, like maybe the volume transformer, or what will we do if we are trying to do a process? As meaning this thing now, since you're using a pipeline, you want to do a pre-processing before, what will you do? Thank you.
Yeah, so thanks for the question. I'll start with the last question. As long as the technique you're using is an sklearn estimator, you can put it in the pipeline. All right, so you can put it in the pipeline. The idea is,
go ahead.
Yeah, so the idea is for simplicity. Now, one estimator that you can use is one-hot encoding. You can do a one-hot encoding on your data, right? Now, remember that the idea is you already have your data, and you have done a lot of assessments on the data, and also the assumption is that you're getting your data from a pipeline, which is the data is coming from maybe a team, and the data engineering team is sending data to you. And then when you receive the data, you are supposed to perform different techniques on the data to, reflect the reality you want the model to, the pattern you want the model to figure. But imagine that you get the data again, you don't have to do that again. You already know the different things you have to do to the data. Maybe the data typically has missing values from where it's coming from, maybe because customers would choose not to put in some features. Think of it like that way. Maybe customers would, right now we have a lot of options for what we want to do. We might choose not to put in maybe the data collection may not show your email address. it may not show your, maybe you have the option of putting your age. And so if the customer opts out of this, then you have data that has maybe a missing value. But you already know what you want to do with the data because you have done it before, but you're not going to do it again. So what the encouragement is that everything you've done in your data, try to see if there are estimators that reflect this. And if these estimators are there, you just put all of them together in a pipeline. And now you now have a model, maybe the name of, maybe it could just be called model_pipeline, and it performs all these activities on your data, then trains it. So you don't have to go through all the steps that you typically go through if you got the data in the first place. Now, remember, the assumption is that your data is coming from a pipeline. That's one. During the learning stage, when you're gaining learning experience, you find that you have to use different data points. They're not coming from a pipeline. When you are when you're in production or before production, you're in a staging setup to understand the problem. Your data would come from a pipeline. So this typically makes it really easy for you to put it together. The strategy for using missing values is typically what you would do with the pandas stuff, right? But remember when I told you, if you had done it the first time and you figured the way or the strategy for which you filled in your missing values, and one of those strategies are mirrored here as an estimator, then you can use that estimator to do the work instead of having to, do mode. Because with the simple imputer strategy here, there's a bunch you can do with it. You can see that you can see when we come to strategies over here, we have if mean, if median, if most frequent, if it's a constant, if an instance of callable, then replace missing values using the scalar statistics returned by running this callable. So the callable basically might be maybe you can see a strategy. Maybe it could be a custom value imputation. It could be something you want it to. Maybe you want it to fill a value. Maybe it could be an extrapolation. You've put that custom value there. With that, you can now use it instead of having to do that through your data point. So it's the same thing. If it was the mean, it's the same mean you have used when you're using pandas, the pandas model. But at this point, you're not going to, do it again. You just basically have a pipeline that affects the strategy for imputation. So yes, it's the same, but we're just doing it efficiently. Any other? But again, remember, like I'll say, my agenda is this: know what you're doing, know how it applies in reality. If you're solving a problem, know that problem. If you don't know the problem, look for a domain expert and have conversations with the domain expert and understand the context for it. If you can, research it. There's a lot that goes into pre-processing of data, exploratory data analysis. It takes a lot of experience. And if you're not close to where the problem is, and most times there's this saying that we try to solve problems that we need to go out on the streets. The problems we need to go out on the streets for, we want to sit down to solve them. What this means is you need to understand the problem. You need to understand how people connect with the problem. And so once you are building a model, you would understand the psychology around a few things, stuff around those things. So yeah, great question. Anyone with a question? All right. Again, you can watch this session again. Please feel free to watch this session again. Again, like I've mentioned, if you're not signed up to the Data Science Mentor Program, please, and you're watching this on a live stream, you can drop a question in the comment section, and I will reach out. Right. If you are signed up to the Data Science Mentor Program, you would receive access to these videos in your drive. And if you are watching a recorded session, feel free to drop a question in the Telegram channel,